Reaching net zero in carbon emissions is a crucial goal for the world, and that goal cannot be achieved without bringing new technologies into play. Such is the case with Helion's nuclear fusion reactors, which are aiming to produce energy in a sustainable way, bringing an end to fossil fuels. The sun is a perfect example of how nuclear fusion can help humans achieve unlimited energy, which can easily solve the world's demand for clean, safe, and affordable energy. But replicating it on Earth is the biggest challenge of them all. Have we cracked the code and finally got the technology to do it? First, let's see how nuclear fusion works. In fusion, two centers of an atom, called nuclei, combine to form a single heavier nucleus. As a result, they release massive amounts of energy. For fusion to take place, it is important for the matter to be in the plasma state. This state of matter is different from solids, liquids, and gases. It is the highest energy state of matter with positive ions, free-moving electrons, and neutral particles. This can be done using three different approaches: magnetic fusion, inertial confinement fusion, and magneto-inertial fusion. In magnetic fusion reactions, a strong magnetic field is used to confine plasma at a very high temperature and pressures necessary for undergoing fusion reactions. The magnetic reactor, which is a kind of vessel where this phenomenon takes place, is completely evacuated so that the necessary environment is created for the reactions to take place. On the other hand, inertial confinement fusion is heavily dependent on achieving a very high density plasma, which with a little temperature ensues a fusion reaction. Also, there is a third type of fusion called magneto-inertial fusion, which, as the name suggests, is a combination of both magnetic and inertial fusion. In this process, plasma is not only magnetically confined, but also compressed to achieve a very high density. The American company Helion has developed a fusion reactor that promises to put an end to fossil fuels and help the world become more sustainable. With the 6th generation prototype Trenta, the Washington startup has so far been able to achieve massive milestones. It is the first startup that has been able to get over the 100 million degrees Celsius temperature in Trenta. This is a critical engineering milestone, as the temperature inside the reactor, close to 100 million degrees Celsius, is not only necessary for fusion to occur, but also is the perfect fuel temperature at which commercial power plants would need to operate. Reaching this temperature limit is not a futile achievement. It is an achievement that many startups in the fusion generator industry have failed to accomplish. Moreover, the Trenta prototype also finished a 16-month testing campaign, completing almost 10,000 high-power pulses, with the frequency of a pulse every minute. All these achievements were lauded, and many people came to support this project to help it achieve its main goal. As of now, the company has achieved funding of more than $2 billion to convert this into a full-fledged solution to the world's energy problems. Expanding on to the great achievements of Trenta, Polaris, the company's 7th generation prototype, is expected to be the world's first fusion generator to produce net electricity. That is, to generate more electricity than it consumes. The approach that Helion follows is different than that of other nuclear fusion reactors. Unlike other nuclear fusion reactors, Helion's nuclear fusion reactor has a simple, linear design devoid of any complexity. Traditionally, a massive donut-shaped device is involved to hold the plasma using very large and powerful magnets. However, Helion has built a long, linear device that works on the mechanism of field reversed configuration, or FRC. The fuel used in the Polaris is deuterium and helium-3, which is injected into the device through the Polaris injector test in short stints at both ends. The electric current flowing in a loop confines the plasma, which is pushed by the magnets at both ends towards each other at a velocity greater than 1 million miles per hour, sending the plasma smashing into each other in the central part of the chamber, where they merge to reach a super hot, dense plasma with temperature more than 100 million degrees Celsius. This is the part of the process where the generation of new energy occurs, and it is recovered through magnetic coils. Some of that energy is used to recharge the capacitors that power the device, and the remaining energy can be used. The most important part of this process, which makes the generation of energy a lot cheaper, is that the system turns fusion energy directly into electricity. As Helion is gathering so much support, there are definitely some things that they are doing that are out of the ordinary. They have built a reactor that is 1,000 times smaller and 500 times cheaper than a traditional fusion reactor. This was achieved due to the Helion reactor's pulsed fusion system. Keeping the device smaller and without engineering complexity is among the hardest physics challenges, which Helion has achieved, which allows it to adjust the power output based on need. Generally, steam turbines or boiling water is used as an intermediary step to convert the fusion energy into electricity. electricity, making the process quite expensive. The process of heating water to create steam to turn a turbine ends up causing a massive loss of energy. However, a linear reactor like Helion can use Faraday's law directly. It uses electromagnetism to charge plasma particles and they induce a current. This massive current helps in the expansion of plasma. The 6th generation prototype, Trenta, could run fusion pulses once every 10 minutes. Polaris is going to push that number to around a pulse a second. This increased rate is going to maximize the energy efficiency of the fusion reactor, which in other words is also called beta. Beta is taken as the ratio of plasma field energy to the confining magnetic field energy. The field reverse configuration of the magnets in the Polaris, according to the company, will have the highest betas of any plasma confining system. When the plasma inside the middle chamber of the nuclear reactor is compressed, the coil with different fields starts to work in combination to help the compression process. Resultantly, the plasma is converted into a radially converging magnetic field. Whereas the traditional nuclear fusion reactor achieves barely a beta of 5%, Helion has the target to achieve a beta close to 100%, which is going to revolutionize the entire nuclear fusion reactor industry. Also, the size of these nuclear fusion reactors is an advantage as Helion's linear reactor is seen in the order of C50 megawatt, whereas the average size of the nuclear fission plant today is around 1 gigawatt. This is very crucial as it can be deployed by individual power consumers or on mobile applications such as in commercial shipping or aviation, as these are on top of the list when it comes to emitting carbon. And until now, it was deemed impossible to reduce their carbon imprint one way or another. Climate change is not something that the world is going to deal with sometime in the future. It is an important issue facing the world right now, and crucial steps are necessary to first reduce carbon emissions and second, completely bring them to zero. And that is exactly what Helion has in their mind with the Polaris reactor. Helion is aiming to produce net electricity from fusion as early as 2024 and to have power on the grid by the end of this decade, 2029 to 2030. However, this is easier said than done, as there are many challenges the company has to overcome to achieve that goal. The road to commerciality is still going to be difficult because there are some negative stories attached to nuclear reactors, and that is going to take some doing to win the trust of people who are eventually going to be on the receiving end of the technology. However, with all its challenges, the lack of flexibility from wind and solar can only be overcome using nuclear energy. Some of France's nuclear reactors, for instance, already cycle from about 1/4 to full power and back again, sometimes twice a day, to compensate for fluctuations in the supply and demand of renewables. That role can be played by fission nuclear reactors such as Polaris with zero carbon emissions. As David Kirtley, Helion's co-founder and CEO, said, "We are building systems that are about the size of a shipping container and that can deliver industrial-scale power, say on the order of 50 megawatts of electricity." Our 2024 date is not a key demonstration of the science at this point. The goal is to go after commercially installed power generation. That's a huge market, and we want to be able to get this out in the world as soon as possible. The goals are lofty and the claims promising. Let's hope that the new technologies like these are going to take the world out of climate crisis and give the world a more sustainable way of using energy.